So there are two more definitions to complete our introductory part. So the 17th definition is De Morgan's laws. So this is a very important stated law so as to use in many of our problems. So be careful enough in listening De Morgan's laws. There are four laws that De Morgan has stated. A union B, the whole complement. You would have remembered this notation is for complementary set. So A union B, the whole dash is equal to A dash intersection B dash. So whatever the operation we are using here, that operation is inverted in the right hand side. So similarly here, if A intersection B, the whole dash is equal to A dash union B dash. So the operations are inverted. Here also the operations are inverted. We shall see what is the third law which De Morgan has stated. A minus B union C is equal to A minus B intersection A minus C. That is, minus is nothing but the difference of two sets. We have already defined it. Next, fourth one is A difference B intersection C is A difference B. Since here it is intersection, we invert that to union, A difference C. So these are all the basic four De Morgan's laws. The last definition for our introductory portion is Cartesian product. For Cartesian product, we can take many number of sets, either 2 sets, 3 sets or multiple number of sets. So the product is defined as follows. So if we take 2 sets to define a Cartesian product, so we have an ordered pair of elements. So the first element is taken from the first set and the second element is taken from the second set. So similarly for the third, 3 sets, A cross B cross C. So here we are taking 3 sets. So our definition comes from a triplet. So the triplet, as usual, the first element is taken from the first set, second element is taken from the second set, third element is taken from the third set. So these are all the Cartesian product. Like this we can extend this result to n number of sets. Okay, now we have a very important property here. The Cartesian product A cross B equal to B cross A. This is nothing but the commutative property which is satisfied if and only if, this symbol notates if and only if. This is the necessary and sufficient condition, the sets are equal. So you might have remembered what are equal sets. Equal sets are what? A is contained in B and B is also contained in A. So this is what? The definition for equality of sets. These two sets are equal if and only if B is contained in A and A is contained in B. Now let us see the examples for these basic definitions.